Okay, so we're going to continue on with binomial distribution scenarios, and we're going to look at Johnson's statistics exam. So Johnson's statistics exam has 20 true-false questions. So we have a specific number of trials. So because I have a specific number of trials, I know I'm looking for a binomial because this is my trials. What is the probability he gets no more than 14 correct? So we're assuming that he's guessing that he didn't study for this thing. So the probability of success is 0.5, and the probability of failure is also 0.5. All right, the probability he guesses correctly is 0.5. The probability he doesn't guess correctly is 0.5. So what's the probability he gets no more than 14 correct? All right, so we've already said that this was a binomial. And we can get 0 correct, 1 correct, 2 correct, ... 13, 14, 15, ... all the way to 20. No more than 14 means these values. Well, that's multiple values, so it tells me I'm working with a CDF. So we have a binomial CDF. Our trials are 20. Our probability of getting it right is 0.5. Probability of success is 0.5. And we need an X value of 14 because that's the highest one that we circled. So here we go. Second vars, binomial, CDF. Trials is 20, 0.5, and our X value is 14. The 0.5 is the probability of guessing correctly. And that's 0.9793 is our answer. Now that's kind of interesting. Because let's think about this. If he gets 14 right, 14 out of 20 is a 70. So there's about a 98% chance that if he guesses, he's going to make a 70 or lower on that test. All right, so he better study it. Otherwise, not likely to pass it. What's the probability he gets exactly 14 correct? So what's the probability he makes a 70 on this test? Well, because this is an exact number, this makes it a PDF. So we're working with a binomial PDF. Our trials are 20. Our probability of guessing correctly is 0.5. And we have an X value of 14. So in this case, second vars, binomial PDF. Trials are 20. P is 0.5, X is 14, and we get 0.0369. All right, 0.0369. Next one. What's the probability he gets less than 10 correct? Again, we have a specific number of trials with 20, so that tells me we're doing with a binomial. Now, less than 10, it could be 0 correct, 1 correct, so I have multiple values. So this tells me I'm working with a CDF. This telling you your scores will improve dramatically if you use the number line technique. All right, so less than 10. Ooh, less than 10 doesn't include 10. That means up to 9. So this is going to be my X value. So once again, my number of trials is 20. My probability of success is 0.5. My X value in this case is 9. So second vars, binomial, CDF, because I had multiple values. Trials is 20. Probability of guessing is 0.5. My X value is 9. And I end up getting 0.4119. So what's the standard deviation and mean? Anytime they say mean, that means expected value. We know we're working with a binomial, so it's NP, which is 20 trials times 0.5 equals 10. And that makes sense. If you were flipping a coin 20 times, you'd expect to get 10 head. So if you were guessing on a test that was true, false, you'd expect to guess 10 correctly and the other 10 incorrectly. So that makes sense. Standard deviation is the square root of NPQ. which in this case is going to be 20 times 0.5. Q is 0.5, as we said previously. And that ends up being the square root of 5, which is approximately 2.236. Okay, next page, we're going to continue with the same scenario. What is, Johnson still has 20 questions. Probability of guessing correctly is still 0.5. What's the probability that gets at least 14 correct? So once again, we know because we have a fixed number of trials, it's a binomial. At least 14 means more than 14. And anytime we see at least, we're going to go 1 minus. So more than 14 or more, that would be 14, 15. So that means we have multiple values. So 1 minus the binomial CDF. Now, we'll make our number line 0, 1, 2, dot, 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 13, 14, 15, dot, 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 all the way to 20. This 14 is at least 14, 15. So all of those values. All right, but because it's a least, it's a 1 minus situation, so we subtract out what we don't want. So this will be our X value. So once again, our trials are still 20. Our probability of success is 0.5. And we want to subtract out what we don't want. So here we go. 1 minus second vars binomial CDF. Trials are 20, probability of guessing is 0.5, and our X value, the highest number we didn't want, was 13. 0.0576. So this is a 0.0576. Now, if he gets 14 or more right, remember we said 14 over 20 is passing, so this is the probability that he passes. If he just guesses, that's the probability he passes. What's the probability he gets at least 10 correct? Once again, we have at least, so we know it's a 1 minus. We already know we're working with a binomial, and at least 10 means 10, 11, 12, etc. So we know it's a CDF. We go make our number line 0, 1, 2, dot, 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 9, 10, 11, dot, 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 to 20. So the highest value I don't want is the 9. That means that's my X value. My trials is 20, my probability is 0.5, and that X value we just found was 9. So 1 minus second vars binomial CDF, 20.5, X value of 9. Check, make sure I got the right answer on the previous one. I didn't list it, so I don't have a check value. So this one I get 0.588. All right, next one. What's the probability it gets more than 10? So more than 10. So 0, 1, 2, dot, 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 9, 10, 11, dot, 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 to 20. So any value 11 or greater. Now this one's tricky. It is, all right? Notice I wanted everything up to 20. Since I want everything up to 20, it's going to be 1 minus what I don't want. Binomial CDF of 20.5, and what I don't want is the 10, because I needed more than 10 correct. 1 minus second vars binomial CDF. Trials are 20. I'm just changing my X value to 10. And I get 0.4119. What's the probability he gets 9 to 13 questions? So 0, 1, 2, dot, 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 9, 10, 11, 12, 13, ... 20. So these are the values I'm interested in. And I should put an 8 there. That's going to help me out. Okay. So that's the values I want. I want 9 as high. I want 9, 10, 11, 12, and 13. Those are the values I want. So I'm going to, because I have to take this top value, which is binom CDF, trousers 20.5. This is going to be my first X is 13. I always take my larger X minus the binom. I have to subtract out what I don't want. CDF, trouser 20.5. And I subtract out what I don't want. I want 9, so I can't subtract it out. I have to subtract the value below it, which happens to be 8. So here we go. This one requires a little bit more work. So second vars, binomial CDF, trouser 20.5, X value is 13, minus second vars, binomial CDF, trouser 20.5, X value is 8, .6906. So there's about a 69% that he gets between 9 and 13 correct. About a 69% between 9 and 13 correct. What's the probability? I mean, 9 to 13. So this is including 9 and 13. This says between 9 and 13. This is being uber tricky. I don't like this, but it is what it is. 0, 1, 2, ... 8, 9, 10, 11, 12, 13, 14, ... to 20. Between 9 and 13 means I want 10 to 12. All right, so since it's between, I can't include 9 and I can't include 13. So this is going to be the binom, and that's just ridiculous being tricky on that. 20.5, 12. Probably give you something like that on an assignment, but not likely to give you that on a quiz or test. Minus the binom CDF of 20, 0.5, the highest value I don't want, make sure you don't include the 10. The highest value is the 9. All right, because that's the value I don't want. So here we go. Second vars, binomial CDF, 20.5. 12 is my highest value up here. Minus second vars, binomial CDF. And the one I don't want here is the 9. So this is my other X. And 0.4565. And that concludes the notes on binomial and geometric. I highly recommend that you go back and practice those things. It'll make a world of difference